Hello once again to TVET Practicals channel with your trainer Mr. Matt Mariko. In this episode, I'm going to train you on how to do measurements, estimation, and costing principles. So in building and civil, we have all these groups of trainees of level 6 doing the same unit. So if you're not done any measurements in your life, this episode is going to be very useful in your life because you are going to understand measurement from practical perspective before proceeding to do estimation and costing principles. So stay tuned and welcome. So let me give you summary of learning outcomes which are borrowed from Quantity Survey Level 6 curriculum. So this element 1, I believe you can read for yourself from various textbooks, and then I'm going to start with the take of quantities. As per this case, we have two major building works, that is substructure and superstructure. So we are going to do for both booking of dimensions and booked items description. Now let me give you some of the examples of the superstructure that we are going to deal with. So number 1 is frame, and in frame we have reinforced concrete and steel. Then number 2 we have walling, then we have roofing, and with roofing we have timber roof, and then we have metal roof. So we are going to again to continue to windows, to doors, to ceiling finishes, to wall finishes, both external and internal, to floor finishes, i.e. screed, tiling, terrazzo, timber, and the rest. Then we are going to continue the staircase and its finishes, then fixtures and fittings, then plumbing works, and we are going to end the superstructure works by these external works. Now, suggested methods of instruction include demonstration by trainer, practical work by trainee, demonstration videos, and this is now where TVET practical channels comes in. I'm going to use a Archicad program to demonstrate through videos how to come up with measurement right from excavation of topsoil up to laying of DPC. So the earlier the better. Even if you have not reached that module, you can start early enough to watch these episodes and then be familiar with how to do measurements. So we have number 4 the projects, and then the last one is the group discussion. So for you as a trainee to do measurement, to do estimation and costing, and any other person in the field, I've borrowed a guidance from Building Technician Level 6 OS, and element 1 is measure the building works. Sub element 1.1 is details of building elements are interpreted as per the working drawings. 1.2 is building elements are taken off according to standard methods of measurement of building and civil engineering works. And you can see the keywords are in bold. So 1.3 is working up process is done as per the building elements. Then this number 1.4 abstracting is carried out according to code of practice. And then 1.5 is building papers are prepared as per code of practice. Then the last one is bills of quantities is compiled according to standard method of measurement of building and civil engineering works. Now, based on those guidelines that we have gotten from OS Building Technician Level 6, let us now take off quantities of the substructure works from the following simple plan now. So this is the plan I'm talking about, and I've given it the code of drawing 01, and it is the plan. So dimension are as follows. Length is 12,000 millimeters from extreme to extreme, and it is having a wall thickness of 200 millimeters, this and this. Width is 8,000 millimeters with the wall thickness 200, this and this. Now we have a cross section AA, that is this one, and this is the explanation of the cross section AA. To start with, against the earth is 50 millimeters thick, plain in situ concrete. Over it, we have a strip foundation concrete, which is again plain and in situ, around 50. Over it here, we have a stone wall, which is 200 millimeters thick, which is natural stone. And then above it, just from this end up to here, which is the ground level, this GL is for the ground level, is 1,000 millimeters. Above the ground level up to the upper part of this slab is 200. Now let me explain this part. These are the explanation of this now up to here. Now down here, we have a hardcore of 310 millimeters. Just over it, this one, this thick one, is the maram blinding, which is 75 millimeters thick.
Then just over it here, we have the 500 DPM gauge, and then we have the BRC mesh ref A198 in between the slab, and then slab itself is 100 millimeters thick. So more I'm going to explain as we take off, and more so I'm going to do demonstration using the Archicad program so that you can understand this one now into deeper details. Before you start everything in takeoff, you must prepare a takeoff list. So number one is excavation of vegetable soil. Number two is disposal on site of this vegetable soil that you have just excavated. Number three is trench excavation. Number four is disposal on site, the soil that you have just excavated when you are digging your trenches. Number five is surface treatment to the bottom of the trenches. Number six is trench bottom blinding. Number seven is foundation mass concrete. Number eight is foundation walling. Number nine is filling to trenches, but now internal before you do the hardcore. Number 10 is filling to trenches, now external for your safety. Number 11 is the hardcore. Number 12 is the mud blinding over the hardcore. Number 13 is anti-termite treatment. Number 14 is DPM. Number 15 is the formwork to the edges. Then number 16 is reinforcement. Then slab work. Then finally the DPC. Now let us start by this subheading 1, which is talking of excavation of vegetable soil. And I hope by now you know these abbreviations from various textbooks. Now, we have it here, excavation of vegetable soil. How do we go about it? You get this area. Now, how do we get that area? First of all, we have a dimension of 12,000 millimeters and 8,000 millimeters. But that is from this now going inside. What about this excess? We have it 600 all over from this end to this end. If you deduct the wall thickness, you remain with 200 for this and for this. And because we are going to excavate catering for this, you add this 200 going this side and another 200 going the other side. So you are seeing me after deducting this 100 from this, I've gotten 400, which I've divided by 2 to get this and this. And then again, I'm going to add this one times 2 because it is this side and the other side. And the overall length will be now 12,000 millimeters plus 400. So it is 12,400. The same case with 8,000, I'm going to add that 400 millimeters to the 8,000. And I'm going to get 8,400. So the area that I'm going to dig now or to excavate for vegetable soil will be now 12,400 by 8,400. And it is here. So when we are now entering them into dimension, we use now meters into 2 decimal places. Then to explain that, excavate vegetable soil average depth of 150, this one now, and preserve on site as directed by SMM clause D3. So go to SMM clause D3 and read it. It will give you this explanation. And we are combining with the element, topic 2, which is disposal on site. How do we dispose this? Now, excavated material disposed on site. Now, this is the distance from where you are doing your excavation in spoil heaps. And you are not required to give any quantity of the soil that you have just excavated. Now, as per this, the explanation will be on SMM clause D15F. Go to SMM and read this clause explaining this now. Now, let us proceed to the video clip to explain this one again now. This one now, from this corner up to this, which is 200, this spread now, that is another 200, making the length to be 12,400. Now, the same thing applies to the width. The width again, you can see the spread from this side now. This spread now, this is what I'm talking about. So that is 200. From this corner to this now, this is 200. So the width was from this external dimension to this external dimension of this wall was 8,000. Now the 8,000, if you add these two spreads, of 200 this side and 200 this side will make 8,400. So that is how the spread is being added to the dimensions. Now, if I have to do the excavation of the 150 millimeters depth, this one now, from this edge to this lower edge, this one is the 150 millimeters. I'm talking about when I'm taking off. Capturing 12,400 millimeters this way and 8,400 millimeters widthwise. So after excavation, still on heading 1, you preserve this now, the way we have preserved them, this one now, we have preserved them on site as directed by SMM clause D3. Now heading 2 is talking of disposal of excavated material on site, and SMM clause D15F talks of that disposal and even the average distance that they are being disposed on. So if I have dug this and then I'm going to dispose them here, average distance of 30 meters from the site. Now this one. Now we talk of heaps. This one is a heap, this one is a heap, this is a heap. And they are on site, meaning we are expecting to use them again at later stages. Off site means they are being thrown away and they cannot be reused again. Now, because we are through with the first heading and the second heading, and it is advisable that if you're through with a certain heading, you take it like that so that you don't get confused in the process. So we are moving to the third heading, which is trench excavation. Now, for us to excavate the trench, first of all, you must get the mean girth. Now, what is the mean girth? Just in between the symmetrical of this one now, we are going to leave 100 up and 100 down. The same with this. So we divide this wall at the center. That is the mean girth now. First of all, the perimeter is this 12,000 times 2. That is this one now times 2. We get 24,000. And then the 8,000, again, for this wall and for this wall, it is that 8,000 times 2. We get 16,000. Now, if you add them, you get 40,000. And then you less corners. That is, this 100 and this 100 makes 200. Now, for this wall, for the mean girth now, this point to this, it is less 100, 100, making 200. So for a single wall, less 200. For another wall here, less 200. For another wall, less 200. And finally, for this one, less this one and less this one. So the formula is 4 times the 200 I'm talking about, which is making, that is giving us 800. So if you deduct this one, you get 39 millimeters, 200. So this one into meters is 39.20. Now let us move to depth. From ground level to upper part of the concrete foundation mass strip is 1,000. We add this 150, this one now, foundation mass depth, that is 150. And then we add the blinding, that is 50 millimeters, this last one, making a total of 1,200. And mark you, when we are starting, we excavated the vegetable soil at a depth of 150. So when we are now excavating for the trench, we are not going to start from the ground level, but from the reduced level that is already 150 depth. So when you deduct that 150 from 1,200 millimeters, you get 1,050 millimeters. So when we are booking here, with the measurements, start with the length and then the width. And the width here is 600 millimeters. Now, when we are now booking this one now, it is 0.60, followed by the depth, that is 1 meter, 0.05. So this is the depth of the trench that we are going to dig. So we have booked this one now. Now, when describing this, excavate foundation trench more than 0.3 meters wide, but equal or less to 1.5 meters maximum depth from reduced level. If you read XMM clause D9 and D5F, explain how to excavate trenches which are more than this and equal or up to this one depth from reduced level. So you are going to get more explanation from SMM. And we are going to combine heading 3 and heading 4 in that disposal of this one now, excavated material on or off the site at average distance of 100 meters. And SMM clause D15F explain this one. In that, after now excavating this, you might as well dispose them on the site if you intend to use them again in backfilling, or off you don't need them now at average distance of 100 meters from the site. Now, this distance will now enable you to quote if they are being transported by a lorry or whichever means. So when we are doing your billing, this you must cater for how they are going to be transported out or off the site. So watch the video clip below explaining how these foundations are being dug at the site.
And the soil that we have excavated along this for the trenches, we have disposed them off the site in that they are not here. We are not intending to use them again. So we have disposed them off the site at a distance of 100 meters, whereby they cannot be visible here. So that is the heading 4 on disposal.
Now let us move to the fifth heading, that is the surface treatment to the bottom of the trenches. Now we have dug your trench, and remember the trench is having a width of 600 millimeters, and the middle gap is from the center, meaning one half is 300 millimeters and the other half is 300 millimeters. So what I've sketched here is the plan overview from above, the extreme ends of the trench and the extreme ends of the trench. So from the middle gap now to the extreme now, half of this one will be now 300. Now, if you hire people to compact this one now, moving by the mean gap, a person from this direction will just reach here, and a person from this direction will just reach here. So you have a corner here that will remain uncompacted. Now, what is this meaning of compaction of treatment of the bottom of the trenches? If you have those people to dig the trench, the bottom won't be that straight. It will have this scenario whereby some parts are deeper than other parts. So for it to be treated and compacted, they are going to adjust it slightly with the soil and then compact it to have a straight now bottom of the trench. So this is the scenario of the treatment of the bottom of the trenches, to have them straight and being compacted before now doing the blinding. So if you read SMM clause D16B, will explain how compaction is being done to the bottom of the trenches. You either do it manually or you hire a machine to do it for you. So watch the video clip below how the bottom of the trenches are being treated.
When compacting this, now let us compact this. We're going to adjust some of this soil here and then we do the compaction. Now you see we have done the treatment, the surface treatment. Now let me take you close range. You see these are soil that we have just returned, very, very close range, and we have compacted this one, and it is now straight to receive now the blinding now.
So if you have to book this one now in the dimension column, you won't use now the mean gap, but you are going to use 41,600 millimeters. Now, how do you arrive at that? You have 300 here plus 300 making 600. And because the compaction is going to be done at the four corners now, you multiply this 600 now, this one times 4 to have 2,400. So this one, if you add to the mean gap, you have 41,600 millimeters, which is the outer face of the trench. So compaction will be done complete now, catering for even these corners. Now, if you have to book it here, you book it as 41.60 meters by the width, which is 0.60 meters. Now, let us move to the sixth heading, that is the trench bottom blinding. So we are going to do that with in situ concrete M7.5 in the ratio of 1:4:8, and it is going to be 50 millimeters thick, poured against the earth. So if you read this SMM, this one now, D16A and F2A will explain how blinding is being done, and deduct ram and fill and add a cutaway. And because we are going to use these two terms more often, let me now explain these two terms, this ram and fill and cutaway. So suppose I have a container containing 1000 liters full, and then I place an object inside the same water having 200 millimeters cubed. What is going to happen is that this volume will displace a certain amount of volume of water that will drip here. Now this first one equal to this. And if I add another one again, 100 millimeters cubed, will displace further water equating to this one now. The same thing now applies to our trench which has been excavated. There was soil which was there initially, and when we have dug that, now it is void. Now if we return the whole quantity of soil, it will be full, assuming it will be 1000 meters cubed. As per that case, no wastage, that is zero. That is the cutaway we are talking about. So the moment we are placing something inside which is 200 meters cubed, for example, we will displace the same amount of soil. So if you have to return the same soil and hire people to ram it, it will be less with this. So long as this one is there, it will be less with this one. So the soil that will be returned now will be this one. If we place another object there, equating to this one now, further soil will be reduced in terms of returning there. This one now taking that place. So simply cut away means the soil that has been displaced, which is supposed to be returned but has been now displaced. So at the end of the day, you will find that you will hire maybe somebody to feed the soil that will be now wasted, that cannot be returned in terms of wheelbarrows or lorries. At the same time, at the same site, the soil that will be now returned eventually to do the ramming and filling will be now less because some of them have been displaced. And now if I have to book this one now, I book is using the min girth now, which is 39.20 by 0.60 meters now. Watch the following video demonstration on how blinding is done to the bottom of the trenches. So let us do the blinding. So you can see now we have done the blinding. This is just demonstration. So we have those blinding along this as well as this one now. So now let us move to the seventh heading. Now this one, that is the foundation mass concrete. So foundation mass concrete, that is this one now above the blinding, this one will be done by in situ concrete class M10, and it is 150 millimeters thick, poured on blinding. So if I have to book this one now, I will book it as using the min girth of 39.20 by 0.60, that is the width of the foundation, and deduct ram and fill and add cutaway. So if you read SMM close F2A, explain how foundation mass are being done. So watch the following video demonstration how the foundation mass looks like at the actual site now. Let us now have that mass. So you can see we have laid a foundation concrete mass. Let me take you close range. So you can see this one now. This is the foundation concrete mass that we have laid over the blinding, and it is 150 millimeters thick, and we have done it round this one. So we have the concrete mass. Now let's move on. And now to the 8th heading, that is this one, foundation walling. Ground level to foundation mass, that is ground level, this GL to the upper part of the foundation mass is 1000, that is this one. Now add above the ground, now from this to this one now, and let's slab. So you come back again now with this 100 millimeters, this one thick slab, to reach now here. So if you have to book that, you book it using the mean girth again of 39.20 by the depth of this one now, but now into meters, which is 1.10 meters, and you remember to close. So the description is 200 millimeter stone wall in stretcher bond in cement mortar 1 to 3, and deduct, ram and fill, and add a cutaway. I think I've explained this concept of deduct, ram and fill, and cutaway, so you are not floating. So watch the following video demonstration how foundation wall looks like in the actual site. Now let us construct the wall. So we have our wall here, as you can see, and it is in stretcher bond, this one, and it is natural stone. This height is 1.1 meters, the way I've explained on the board. So we have our wall ready. Now let us move to the 9th heading, that is filling trench, but now let us start with the internal. Remember when we were digging for the trench, there's a void here. If you do article without filling this, we are going to have some wastage now. So we need to fill this one, and how to go about it? The length is 12,000 millimeters. If we lessen the wall thickness from this side and from this side, we are going to remain with 11,600. That is this one now. The width is 8,000. If we lessen it by 400 now, wall thickness of this and this, that is this one times 2, we're going to have 7,600 millimeters. Now, the filling girth, how to get that one now? Remember now we are going to use this one as our external dimension. And the void we are talking about, let us assume it is this, it is this, it is this. So it is this void now. But we want to get the mean girth now, so that we know how to do it now, the filling. So the mean girth, as I've told you, this one now, which is our, as per this case, our external now, but now internal here, we lessen the 4 corners, that is 800, and then we get this one. So if you have to book this one, it's going to be 37 meters, 0.60. Now, what about the depth? What about the depth now? Now, the depth is initially from ground level to this upper edge of the concrete mass, 1000. If we lessen the reducing level, which is 150, remember we reduce the level first of all. So from this to this is 150. If we subtract this, or if we deduct this from this, we get 850 millimeters. So when we are booking, it is in meters, 0.85 meters, and then we close. So when we have to explain that, it is return, fill, and ram selected, not just any material, excavated material around foundation, but now internal. Remember that. If you read SMM close D15C, explain how to backfill. So watch the following demonstration video to know more about this void now and how to do it. And every time you're through with an element, take to avoid confusion.
So we want to do filling to the internal trench, this one here. Remember when we dug this, it was cutted for this spread. But now before we place any hardcore here, some hardcore will be now filling this, resulting to a lot of waste. So we must fill this one with this soil that we excavated and deposited on the site. So we are going to select materials here and then fill this one up to level. So now let us fill it. So you can see now
we have filled this one. So this one is the backfill from this to make it now one level. So when we are going to lay our hardcore, it is going to be on a flat surface. And we have done it all through, all around. You can see all this void has been now filled. Now what we have done to the internal void, that is the filling, we are going to fill again now, but now for the external. Now why do we do the filling to this outside part? Because when there's a void here, it can result to some major injuries when workers are now doing some construction work. Some might even fall here. So we need to fill it now for their safety. So how do we go about it? Remember, if there's a spread going inside, when we are now reducting, now we are going to add because we are going to do it outside now. So for the 12,000 millimeters, we are going to add 400. That is the spread this side and the other side, as well as the width. We are going to add the same 400 for the 8,000. So these 12,400 and 8,400 will now add new dimensions. So if we multiply them by 2, because they are for the 2 walls and again for the 2 walls, we're going to have this one giving us this, and again this one giving us this. If you add them, we're going to have 41,400 millimeters now. We are going now to lessen the corners. The procedure is just the same. Now, if you lessen the corners again to have this mini girth, now this mini girth now, but to the external, we're going to have this 40,800. So if you are to book that, we're going to book it as 40.80 meters. Now, what about the depth? Remember, we did not do the reducing level to the outside part. So it is just solid 1,000. That is this one. So now the depth is 1 meter.00. So if we have to explain that, it is approved selected material filling around foundation, but now the void is 200 millimeters wide around the foundations. You can now read more on SMS clause D15C. Now watch the following demonstration by Archicad program, how the filling is being done to this external void. Now, let us now fill this one now, because it might pose threat to those who are working here, this one here. So let us now fill it. So if you are keen, let me show you. We have done the filling all around. You can see here has been filled with this soil that was deposited here. You can see this one has been filled, as well as this side. This one now. Now let us move to the 11th heading, that is the hardcore, and we are going to do it inside this building, meaning from the other end up to this wall. So the internal dimensions we have calculated earlier, they are these ones. So if you have to book this one, we are going to write 11 meters.60. That is for the length, and the width is 7.60. Now, if you read SMM clause D20A, B, and C, states that if the thickness of a hardcore is exceeding 300, like this one now you can write it now here. So we are going to write as 0.31 meters, and then we remember to close. So they are going to be compacted in layers. Why? If this is the thickness of a hardcore, now the first 200, now this one, the first 200, this one, will be majorly bigger hardcore, but now some of them might protrude because they are big. But now adjust this 100 by smaller pieces to have this level now. So first of all, compact this one, and then complete this one with 110 to have this top part leveled. So watch there, and then deduct ram and fill, and then add cutaway. So watch the following demonstration, how the hardcore are being done at the site. Now, if this is the site, you can see I'll place the hardcore from this end all the way up to this midway. Now, let me take you and give you the side view, how
the hardcore may look like in reality. Now this is the upper end and this is the lower end. This thickness is 310 millimeters. And now let me complete this part which is remaining. I have placed the hardcore all the way up to this end now. Now take a close look.
Now let us move to the 12th heading, that is the maram blinding. Now, over the hardcore here, this small gap is that maram blinding I'm talking about. Under this heading, it is explaining even the thickness over this. It must be 75 millimeters thick, maram blinding on this hardcore now. Now, if you book this, it is going to be 11.60. That is the length of the room, and the width, that is 7.60, and then close. And then you explain the thickness of that blinding over this. In SMM close D16A will explain more on how blinding is being done. So watch the following demonstration how this one is being done over the hardcore.
This is maram blinding. I've done it from this end all the way up to here. Now let me give you a close view. So this is the thickness of the maram, which is 75 millimeters according to our cross section. So let me now complete it from this end now all the way up to here. So I've done it from this end all the way up to here, and our blinding is now over, as you can now see.
Now let us move to heading 13, that is anti-termite treatment. So it is being done over the blinding which was done over the hardcore. So when explaining that, anti-termite treatment to blinded surfaces of hardcore. And if you need SMM close D2A, explain how anti-termite is being applied at the site. So if you book this, you book it as an item and watch the following demonstration how the surfaces where the anti-termite is being applied.
So anti-termite is poured over all this place to keep off insects that might invade this building in the future. Likely they can cause a lot of destruction, especially on the wooden parts, doors, wooden doors and the rest. So anti-termite is being poured all the way now to keep them away. So it is treated as an item. There's no way I can demonstrate that now using an Archicad program. So just take it that anti-termite is being poured all over this place.
To 14th heading now, that is the DPM. So over this blending, just before the concreting, in between here, there is DPM, that is the damp-proof membrane. So it is being laid over the blinding to prevent penetration of moisture to the concrete now. So it is done to the entire floor, to this extreme, up to this extreme, all the way to this and this. So when booking that, you use now the external dimension for the area, that is the 12.00 by 8.00, and then you close. And now explanation is 500 gauge polythene sheeting done as the DPM. So if you read SMM close G96 and G97A, explain how the DPM is being laid over the blinding when construction is being carried. So watch the demonstration video how it is being spread over the blinding which was done over the hardcore.
So now you can see I've spread the DPM from this end all the way up to here. So may I give you the side view how the DPM looks like in reality by demonstration. So after I have done this, Let me now complete it from this end now up to this end. So we have covered our blinding, that is the Maram blinding with the DPM. So you can see how the DPM looks like by demonstration.
Now let's move to the 15th heading, that is the formwork. Remember, this is a concrete, and at the edge you must place a plank of wood to prevent it from now collapsing outside. So by doing that, how do you get that all around? So formwork to the external perimeter as above or as before is that you get the perimeter all around. And how do you get that? It is twice the length, that is this one and twice the width, that is this one and this one. So formwork, simply you are going to do it all around. So if you add this, you get 40,000 millimeters. So if you book that, you book it as 40.00 meters. Now explaining that, it is shown formwork, this one, to edges of the bed, that is 100 millimeters high, this one now. So you do it as the thickness of the slab now, this one. So if you read SMM clause F19A and F21A, you'll get more information how the formwork are being constructed just before pouring the concrete slab. So watch the following demonstration how the formwork is being done to the edges of the structure before pouring in this in situ concrete.
Now let us have a formwork all around this edge now, so that when we pour our in situ concrete, remember it is wet, it won't spill over. So we have our formwork ready. Now let me give you a close look from this upper end to this lower end. This one is now 100, equivalent of the thickness of the slab. And you can see this is a formwork which is wood. So that is how formworks are being placed.
Now let us move to the 16th heading now, that is the reinforcement. So BRC mesh ref this number mass this is being placed over this structure now using the extreme dimensions, that is 12.00 meters by 8.00 meters. So if you read SMM clause F17A and F17B explains more how BRC mesh are being laid over just before the slab work. So watch the demonstration video that I've demonstrated how the BRC mesh is being placed just before doing the slabbing of in situ concrete.
Now I want to place the mesh here. So this is the mesh I'm talking about. So you can see how it looks like. Now let me take you close range. So you can see this is the mesh. Of course, I have not demonstrated how the spacers from the downer part are placed, but in general, you can understand how the BRC mesh ref 198 is being placed before now pouring the in situ concrete to have it strengthened by this BRC mesh.
Now let us move to the slab work, this one. So after you have placed your BRC mesh, you are now going to pour in the in situ concrete and then vibrate. So how do you explain that? In situ vibrated reinforced concrete M15 with this ratio of mix 100 millimeters thick bed, that is this one now, which has been explained here. So after placing the mesh, you are going to pour in situ and then vibrate this one now using a machine. So if you use SMM clause F1A, F2A, F5A, explain how the concrete are being placed. So how do we book that? Because we are going to use still extreme ends. You are going to use the area that is 12.00 meters by 8.00 meters. And because the thickness of this does not reach 300 millimeters, we state it here in the description column. So watch the demonstration below how this slab work is being done.
Now you can see I've done the slab work from this end all the way up to here. Now let me now complete it up to this end. So you can see I've done the slab work. Let me take you close range so you can see. This is the slab work now. It has been contained by this formwork now, this one. Now our last takeoff heading will be DPC. So I'm going to place the DPC, that is the damp-proof course, along this edge of the slab. And you can see now I've placed it now. Now let me give you a close range how the DPC looks like. So you can see the DPC I'm talking about. It is this one now, where we are going now to start now constructing our superstructure. So that one will mark the end of this Archicad tutorial and demonstration. And if you are new in measurement, I think now you will understand most of the concept as we move along. Thank you for watching.
And at last, now let us close our taking off by this one. This is the DPC, damp-proof course. Remember, our title was drawing number 1, that is this one. Taking off of substructure works up to including DPC now. So we have included it here. Remember, we started from this lower end up to this now. So we are going to close our taking off, including this DPC. So how do we explain that? A DPC of width 200 millimeters across the wall, meaning that as above, that is this one, 39.20 meters, and remember to close. As above means we have calculated the same length somewhere else above as we are now proceeding with our taking off. So if you read the SMM clause G97A, explain how the DPC is being laid across the slab work just before the superstructure commences. So that is going to mark the end. And remember, when you are closing or when you are now through, like as our case, you must write end of substructure work and refer to the drawing number so that the person following your work might know where you started your work and where you have ended. So watch the demonstration video which I've done using the Archicad program explaining how the DPC are being laid over the slab work.
Now our last takeoff heading will be DPC. So I'm going to place the DPC, that is the damp-proof course, along this edge of the slab. And you can see now I've placed it now. Now let me give you a close range how the DPC looks like. So you can see the DPC I'm talking about. It is this one now, where we are going now to start now constructing our superstructure. So that one will mark the end of this Archicad tutorial and demonstration. And if you are new in measurement, I think now you will understand most of the concept as we move along.
Now, thank you so much for watching the session since I started. But now let me remind you that since I started, I've been leaving this first part of measurement, whereby details of working drawing are interpreted. And indeed, we interpreted that working drawing, that plan, if you can remember. And from it, you are able to take off. So since I started, I've dealt with these first two. That is the working drawing interpretation and the taking off. Now subscribe for this second part, estimation and costing principles, whereby we are going to do the working up. Now at these stages whereby we are going to use the squaring column by multiplying the areas, by multiplying the volumes and getting the actual volumes. And then from there, we are going to do the abstracting And then from there, we're going to prepare the billing papers, this one. And then we are going to complete everything now by compilation of bills of quantity, this one. So this is the climax of our session. So please subscribe for this working up to this last one, so that you get well acquainted with full knowledge of how to take off quantities up to the billing of quantities. And as for now, bye-bye and see you next time.